looking at the interpretation of functions. The graphs of f at x and g of x are given below. The graphs intersect at -2 is to 0 and 4 is to 6. 5.1. Use the graph to determine the values of x for which f at x is equals to g of x. So in this case, they are looking for the x values where the graphs meet. So this is the point of intersection. Let's look at our sketch. The graphs meet at x is equals to -2 and also at x is equals to 4. The solutions will be x is equals to -2 or x is equals to a 4. 5.2. f of x divided by g of x should be greater or equals to a 0. In order for something to be greater than 0, it must be what? Positive. Okay. So when I have a fraction, I need to divide something that is negative with a negative value. And then my answer there will be what? A positive answer. Or I should have something that is positive divided with a positive thing to have my solution being positive. Okay. I will have an f at x there, and then I will also have a g of x. I will have two scenarios. In the first one, I need to look at where my f at x will be negative and where my g of x will be negative, so that I'll get something that is positive. Negative and negative will give me a positive solution. And then in the second scenario, I need to look at where f at x is positive and where g of x is positive. Let's go to our sketch. So I'm going to look at where f at x is negative. In other words, where f at x is below the x-axis. F at x is below the x-axis from that point going down. It is also negative or below the x-axis from there going down. Okay, we are done with f at x. Now let's go look for g of x. Where is g of x below the x-axis? G of x is below the x-axis from that point to the left or downwards. So it means that my solution should lie here, because at this point where my f at x is below, g is above, so I cannot include that side. So my x should be less or equals to -2. However, it is very important to note that g of x is at the denominator. We cannot divide by a 0, because then we would have an undefined solution. Let's go back to our sketch. Notice how when x is equals to -2, g of x is equals to 0. So the y value when x is equals to -2, the y value is equals to 0. So we cannot include that solution -2. X should just be less than -2. Or we are looking at the second scenario. F at x should be positive. F at x is above the x-axis between those 2 points. And then g of x is above the x-axis from there to the right. Okay, so our x should lie between a 6 and a negative 2. We said that we cannot include the negative 2 because there the y value is equals to 0. So g of x will be equals to 0. But this side, f at x is equals to 0. Since it is above, or it is the numerator, we are going to include the negative 6. I hope this makes sense. 5.3. They want to know where I can multiply the gradient of f at x with g of x and get something that is greater or equals to 0. Again, the only way to get something that is greater than 0 is if I take a negative and multiply it with a negative. This will give me a positive. Or I take a positive, multiply it with a positive, and the result will be a positive. F prime of x and then g of x. I will have two scenarios. I want to find the x value when the gradient is negative and where g of x is negative. That way I will get what? A positive solution. Or where the gradient is positive and where g of x is positive, and then my solution will be positive. So we look at the first scenario where the gradient is negative. At the turning point, if I were to draw a tangent at the turning point, the gradient of the tangent will be equals to a 0. Okay. And then if I were to draw a tangent at any point to the right of that turning point, my gradient would be what? It will be negative, because whenever I have a straight line that looks like that, the gradient is negative. And then if I were to draw a tangent to the left of f, the gradient would be positive. Okay. So now I need to focus at where the gradient is negative. The gradient is negative on this side of f. And then I need to look at where g of x is below the x-axis when the gradient is negative. Well, you can clearly see that from this point to the right, g of x is above the x-axis. So we do not have a solution for the first scenario. Okay. Now I am going to look at where the gradient is positive. And then I need to find where g of x is above the x-axis. We said that at the turning point, the gradient should be equals to a 0. So I cannot pass this point. My solution should lie from this point to the left. So my g of x is positive from there to that point. Okay. So I need to find what the x value is at the turning point. X should be equals to negative b over 2a. And then my x value is a 2 over 2. And then my a should be negative 1 over 2. So this is going to be equals to 2. My x value there is equals to a 2. Okay. So it means that my solution will lie from this point to that point. Okay. So my solution should be x should be between negative 2 and a 2. Okay, and then both will be included.